Level 0. Welcome to Level 0. This is where space begins, and where Earth finally lets go of your hand, but just barely. You are still close enough to see the continents, the oceans, even the glow of cities at night. It feels like a gentle step into the cosmos, but looks can be deceiving. Near-Earth space includes the region just above our atmosphere, stretching out to around 1,200 miles. This is where the International Space Station orbits. It is where thousands of satellites buzz silently around the planet, and it is where one of the least talked about but most serious problems exists: space junk. Right now, there are over 30,000 tracked objects orbiting Earth. Not just satellites, debris, leftover rocket parts, chipped paint, discarded gloves, and even a wrench that floated away during a spacewalk. These fragments are moving at speeds over 17,000 miles per hour. That means even a flake of metal could slice through a spacecraft like butter. So yes, Level 0 may be the starting point, but it is already trying to kill you with extreme speed and poor cleanup habits. Communication here is still instant. Astronauts aboard the ISS can talk to ground control in real time. Repairs can be directed from Earth. Rescue missions are possible, though difficult. You are still within what engineers call a survivable envelope. The Earth is right there, comforting and enormous. But even here, space is hostile. Temperatures swing wildly. Oxygen is non-existent, and the vacuum of space is unforgiving. One wrong move, and the nearest hospital is 250 miles straight down through gravity, fire, and re-entry. Farther out, just beyond this satellite swarm, lies Cislunar space. That term means everything between Earth and the Moon. It sounds straightforward, but this region has been mostly empty since the Apollo missions ended. Now it is making a comeback. NASA's Artemis program aims to return humans to the Moon. Private companies like SpaceX have plans to launch cargo and crew across this zone. It is becoming the new frontier for construction, exploration, and eventually, colonization. The Moon itself sits roughly 240,000 miles from Earth. That might seem far, but it is basically the front yard in cosmic terms. Still, the risks jump dramatically once you cross into this zone. Radiation from the sun increases, communication delays start to appear, and if something fails, you cannot just turn around and come home in time for dinner. Level 0 is deceptive. It feels safe because Earth is still in view, but it is already a battle against physics, engineering, and silence. It is where humanity learns to let go, piece by piece. But once you cross past the Moon, that comfort starts to vanish. Earth becomes a dot, communication slows, and the path ahead becomes a one-way journey into deeper, stranger territory. Level 1 is next, and the real isolation is about to begin. Level 1. You've left the Moon behind. Earth is now a tiny glowing marble in the distance, and suddenly space feels different. Welcome to Level 1, also known as interplanetary space. This is the vast, silent territory that stretches between the planets of our solar system. And let's be clear, it is not just empty space. It is a massive, shifting minefield of solar radiation, orbital mechanics, and cosmic indifference. Once you enter this level, your mission changes. You are no longer just surviving near Earth. You are navigating deep space with a target that could be millions of miles away. Mars? Venus? Jupiter? Pick your destination, but understand that getting there is anything but simple. Travel time is no longer measured in hours. Now you are dealing with months or even years. That means long-duration isolation, resource planning, and a whole lot of trust in your math. And then there is the sun. The friendly ball of light that once gave you warm summer afternoons is now a deadly force. In interplanetary space, you are fully exposed to its wrath. There is no magnetic field out here to protect you, no thick atmosphere to filter radiation. Solar flares and coronal mass ejections become legitimate threats. One bad burst of energy and your systems could fry. You do not want your life support relying on a sunburned circuit board. Let's not forget the communication lag. When you are this far out, the delay becomes obvious. Talking to Earth is no longer instant. A message to Mars, for example, can take anywhere from 5 to 20 minutes to reach mission control. If something goes wrong, there is no quick fix, no immediate help. You are on your own with nothing but a plan and a prayer. Despite the risks, we have done it. Robotic missions have conquered this level. Voyager, New Horizons, the Mars rovers, and countless probes have explored the planets, collected data, and sent back images that changed how we see the solar system. But they are just the scouts. Human exploration of interplanetary space is still in its infancy. That is why upcoming missions to Mars are such a big deal. They represent the moment we test whether humans can really survive long-term space travel. Not a few days in orbit, not a quick trip around the Moon, but a full-scale journey across the solar system. If we pull it off, we change our future forever. But even Mars is still part of the Sun's kingdom. Interplanetary space is wild, yes, but it is still ruled by the same star that warms your face on a clear day. The real shift happens when you leave the sun's bubble entirely. Past the planets, past the edge of the heliosphere, something unfamiliar begins, and that is where Level 2 begins to whisper. Interstellar space is waiting. Level 2. If you thought space was empty before, welcome to Level 2. This is interstellar space, the vast freezing gulf between stars. And once you're here, there are no planets nearby, no sunlight to warm your ship, no cosmic pit stops. Just you, your vessel, and distances so large they start to feel meaningless. Technically, you enter interstellar space once you leave the sun's protective bubble. That invisible shield is called the heliosphere, and it is formed by the solar wind. As long as you are inside it, the sun still has some control over your environment. Once you pass through the outer edge, known as the heliopause, you are free from the sun's influence. But that freedom comes at a cost. Right now, only one human-made object has ever entered this realm. Voyager 1. Launched in 1977, it took 35 years to reach the edge. In 2012, it officially crossed into interstellar space, and what it found was both exciting and terrifying. The temperature dropped, radiation levels spiked, and the sun's voice, once a loud constant hum in its instruments, went completely silent. Out here, nothing is close. The nearest star is over 4 light-years away. If Voyager 1 was headed toward it, and it is not, it would still take another 70,000 years to arrive. That is not a typo. 70,000 years. You could binge every show ever made, twice, and still not even be halfway there. The space between stars might seem empty, but it is not truly a vacuum. There are scattered atoms, rogue particles, and dangerous cosmic rays drifting through this cold abyss. These rays are a problem. They are high-energy particles that move near the speed of light, and if you are not protected, they can damage electronics, cells, even your DNA. Interstellar space does not mess around. Communication is another challenge. Even at light speed, messages can take years to travel. A phone call from here? It is more like a postcard with a multi-decade delivery time. This level pushes the limits of everything we know about spaceflight. Propulsion, shielding, even the psychology of isolation. It is not just a matter of building a ship. It is about keeping your mind intact while floating through a place with no clear end. But there is beauty here too. In this quiet, star-speckled void, you are seeing the galaxy from the outside in. You are no longer part of a single solar system. You are drifting through the darkness between worlds, surrounded by light that began its journey long before humans existed. Still, you have not even left your home galaxy. There is something bigger coming, something much stranger. Because level 3 is where stars become scenery. Galactic space is next, and nothing is small there. Level 3. Now we enter level 3, galactic space. This is where everything you thought was big suddenly feels small. Stars become specks, solar systems fade into the background, and your surroundings are no longer just cold and dark. They are ancient, powerful, and completely beyond human scale. At this level, you are no longer drifting through space between stars. You are moving through the galaxy itself. Our home galaxy, the Milky Way, is a swirling disk of over 200 billion stars. It stretches across more than 100,000 light-years. Inside it are clouds of gas, dark matter you cannot see, and gravitational forces that twist and pull everything into motion. This is where black holes become part of the landscape. At the center of the Milky Way is a monster known as Sagittarius A, a supermassive black hole with a mass more than 4 million times that of our Sun. It sits in the heart of the galaxy, completely invisible but pulling stars into wild orbits like toys circling a drain. Scientists once doubted it even existed. Now we have seen the effects clearly. Stars whipping around an invisible point at impossible speeds. That is not theory, that is observation. As you move through galactic space, you also begin to see just how chaotic this level can be. Supernova explosions light up the darkness. Entire star systems can be torn apart by gravitational tides. Pulsars spin like cosmic lighthouses, sending beams of energy across space at incredible speed. There is beauty here, yes, but also violence. And then there is time. Galactic time is different. Light from some of these stars has taken tens of thousands of years just to reach you. You are not looking at what is happening now. You are looking into the past. Every direction is a glimpse at events that unfolded long before humans even existed. Even navigation changes at this level. In interstellar space, you might chart a course from one star to another, but in galactic space, you have to think in spirals. You are moving along the curved arms of a rotating galaxy that is constantly in motion. Everything here is being pulled towards something. Nothing is still. Despite its size, the Milky Way is just one of hundreds of billions. So as massive as this feels, you are still just swimming inside one cosmic ocean. The edge of the galaxy is not a wall. It is more like a fog that thins out into the void between galaxies. And in that void is the next level, because level 4 does not just take you past stars, it takes you past everything. Intergalactic space is next, and there the silence becomes absolute. Level 4. Now we step into level 4, intergalactic space. This is not just the space between stars or planets. This is the space between galaxies. The space where light fades, where distance becomes almost meaningless, and where even gravity begins to loosen its grip. When you leave the outer edges of a galaxy like the Milky Way, you do not immediately find something else. You find nothing. No stars, no gas clouds, no orbiting systems. Just an endless black sea scattered with faint traces of light that took millions of years to reach you. It is hard to even describe how empty this region truly truly is. In some directions, you could travel for millions of light years without encountering a single atom. And yet, the emptiness is deceptive. There is structure here, hidden in the dark. Long filaments of gas and dark matter connect the universe like threads in an invisible web. These cosmic bridges link galaxy clusters together, forming what scientists call the large-scale structure of the universe. Between those threads lie cosmic voids, huge regions of space where nothing exists. No galaxies, no stars, just silence. This is also where the laws of physics start to feel less familiar. The farther you move into intergalactic space, the more the expansion of the universe takes over. Galaxies are not just drifting apart, they are accelerating away from each other. At some point, distant galaxies become unreachable. Even if you could travel at the speed of light, the space between you and them would keep stretching faster than you could move. There are no rescue missions here, no nearby systems to call for help. In fact, if your ship's lights went out, there might be nothing reflective around you to even notice. You would vanish into a place so dark and so remote, it would be as if you had never existed at all. But not everything is still. Some theories suggest this emptiness may be filled with rogue objects, entire planets that were thrown out of galaxies, black holes with no stars, radiation from the early universe still echoing faintly across the cold. This level is a reminder that the universe is not just big, it is lonely. Galaxies are islands, and this is the ocean that separates them. And yet even this ocean may have a boundary. There is one more level, one final place where even the rules of reality might not apply. Because if you travel far enough, and fast enough, and somehow escape the reach of everything we know, you reach the edge of thought itself. Level 5 is beyond the universe, and what waits there, no one can say. Level 5. Level 5 is different. At every level before this, we have explored regions we could map, places where science, observation, and data gave us something to hold on to. But now, we are leaving even that behind. Beyond the universe is not just another location in space. It is a question wrapped in theory, waiting in silence, and echoing through the limits of our imagination. First, let's define the edge. The observable universe stretches roughly 46 billion light-years in every direction. That number is not the age of the universe. It is the distance light has traveled since the Big Bang, taking into account the expansion of space itself. Beyond that, we do not know. Not because it is empty, but because light from those regions has not had enough time to reach us. The laws of physics may still apply out there, or they may not. Some scientists believe the universe is infinite, that if you kept traveling in a straight line, you would never find an edge. You would simply pass more galaxies, more space, and more time. Others propose something far stranger, that our universe is just one bubble in a vast cosmic foam, an endless sea of other universes, each with its own laws of physics, its own version of time, even its own forms of matter. This is the realm of the multiverse theory. It suggests that what we call the universe is just a small patch in a much larger reality. Some of these other universes might be similar to ours. Others might be so alien that we would not even recognize them as real. Dimensions could bend. Time might not exist. Light might behave in ways we cannot model. Even the concept of space itself could break down. There are ideas that black holes might be gateways, that each one could contain a universe of its own, sealed off and unreachable. There are theories from quantum mechanics that suggest our universe split into countless copies the moment you made your last decision. And there are models that propose our universe could be a simulation, part of something programmed rather than born. All of it is speculation, but not without reason. The math behind some of these theories is solid. What we lack is evidence, and until we find a way to test it, the space beyond the universe remains the ultimate mystery. You have passed Earth's orbit. You have crossed through planets, stars, galaxies, and the dark sea between them. Now you are at the final veil. No coordinates, no maps, just questions. And maybe that is the real frontier. Not a place, but a challenge. A dare to keep looking, keep asking, and never stop reaching. Because the moment we stop wondering what is beyond, we stop moving forward. And now, at the edge of it all, only one question remains. What do you think is beyond the universe?